Hello everyone. In this session, let me continue few more problems, and it is important problem. Here is a problem. Evaluate integral z minus 3 divided by z square plus 2z plus 5, where curve equation is given by mod z plus 1 plus I is equal to 2. So it is not in a standard form of a circle, but anyhow it is a curve equation is given. Fine. So to solve such kind of problem, the method is slightly varying. But before that, let me explain. So let me solve the denominator. It is anyhow quadratic equation, so solve by using a formula method. So when you solve this by using formula method, I have solved this in the previous problem also. If you want, you can refer that, or else let me solve. Z is equal to minus b plus or minus b square minus 4ac divided by 2a. So b value is minus 2 plus or minus b square is 4 minus 4 into a is 20 divided by 2. So I can write this as minus 2 plus or minus I into square root of 16 I'll get. So 16 is another than 4 divided by 2. So let me take common factor. You will get z as minus 1 plus or minus I into 2. Here the values of z is minus 1 plus I into 2 or 2i, and beta is, let me take this as alpha, and one more value is minus 1 minus 2i. Fine. Minus 1 plus 2i. So meaning is given integral can be expressed as, so in the denominator can be written as z minus alpha into z plus alpha in z plus beta. I'm sorry, z minus only, right? Z minus alpha into z minus beta into dz. If you want, you can substitute alpha value and beta value in the place of alpha and beta, and substitute, you will get back the denominator. So that is what the factorization method is. I can express denominator as z minus alpha into z minus beta dz. Now the question is, we have to check whether alpha and beta lies inside the circle or outside the circle. So where the curve given matters. So let me write the curve. Z plus 1 plus I is equal to 2 is a given curve to us. Now what you're going to do is, first let me check for alpha. Fine. So alpha is equal to minus 1 plus 2i. Now you have to replace z with alpha. If after simplification, if you are going to get whatever the value you are going to get, if it less than 2, obviously it will be inside the given curve. Fine. If it is greater than 2, it will be outside the curve. Just a logic. Suppose let me take this as a circle. So if a circle is of radius 2, if the simplified value you have obtained it as greater than 2, it will be outside the circle. If it is less than 2, it will be inside the circle. No matter whether it is a circle or hyperbola or parabola, whatever may be the curve. So first replace z with alpha. So what is the alpha value we have? Let me do directly. Minus 1 plus 2i plus 1 plus I. Let me simplify. Plus 1 minus 1 get cancelled. Here what I have is 2 plus 1 is 3i. So how you are going to obtain modulus of x plus iy value? It is square root of x square plus y square, right? So here I have, in place of x I have 0. 0 plus 3 into I. It is equal to 0 square plus 3 square. So 3 square with square and square it get cancelled. You will get 3 only, right? Anyhow 3 is greater than 2. Right? So 3 is greater than 2. In the sense 3 is greater than 2, meaning is 3 lies outside the circle, right? So I can clearly write that alpha lies outside the given curve or given circle. Fine. Why? Because obtained value is greater than the given radius, it is 2. So alpha lies outside the circle. Clearly I have told you, when the curve lies outside the circle or outside the given curve, we can say by Cauchy's integral theorem, Cauchy's integral theorem, the value goes to 0. Now let me check for beta also. So what is the beta value I have? Beta is minus 1 minus 2i, right? So let me replace in the given curve z with minus 1 minus 2i. Minus 1 minus 2i plus 1 plus I. Fine. Minus 1 plus 1 get cancelled. You will get minus 2i plus I. Minus 2i plus I will be minus I. So when you are going to calculate by applying this concept, 0 square plus minus 1 whole square. So you will get 1. Now you can note that 1 is less than 2. Right? 1 is less than the given curve 2. So 1 lies inside the given curve. Shall I write? Beta lies inside the given curve. Fine. So beta lies inside the given curve. Hope so it is clear now, right? Now let me solve for alpha case. Let me do here. Since alpha lies outside the given circle, right? So let me write the given problem. I can write the given problem as z minus alpha into z minus beta. So let me write here z minus 3 divided by z minus alpha into z minus beta into dz, right? Since alpha lies outside the given curve, outside the given curve, fine. So I'm talking with respect to alpha, right? So let me take this as f of z, fine. So let me take this as f of z. I can write this as f of z divided by z minus beta. When you talk about beta, I can write this, since we are talking about alpha, right? So let me take this as alpha, f of z. So I can retain alpha as it is. So if you are going to talk about beta, how can I write this as z minus 3 divided by z minus alpha into z minus beta into dz. Anyhow, beta lies inside. So if it lies inside, I am talking with respect to beta. So you have to consider beta and you have to leave alpha. So you are going to consider this as f of z. So I can write this as f of z divided by z minus beta. Right? Now since alpha lies inside, we are talking with respect to alpha. So I am considering beta as a function. Z minus 3 by, I'll write here where f of z is equal to z minus 3 divided by z minus beta. Since alpha lies outside, therefore by applying Cauchy's integral theorem, this value goes to 0. Now with respect to beta, it lies inside, right? So now we have to apply Cauchy's integral formula. Why? Because it lies inside, where f of z is given by z minus 3 divided by z minus alpha. Fine. So when you apply Cauchy's integral formula for this function, I can write this as 2 pi I into f of beta. It is of the form f of z divided by z minus a, right? So when you have in this form, as per the formula, what we can write, 2 pi I into f of a, right? Now f of z, in place of f of z, I have z minus 3 by z minus alpha. I have written here. In place of a, what we have? Beta. So I have to write f of beta here. That is what I have done. Now what I need to find is f of beta value. So let me write, in order to avoid confusion, I'll write small f only. Fine. So f of beta I need. So in place of z, what I'm going to do is I'm going to replace it with beta. Beta minus 3 divided by beta minus alpha. Fine. Let me simplify now. What is the beta value I have? I've simplified here. Beta is minus 1 minus 2i. Let me substitute here. Minus 1 minus 2i minus 3 divided by minus 1 minus 2i minus alpha is minus 1 plus 2i. Minus 1 plus 2i. Let me simplify. Minus 1 minus 3 is minus 4 minus 2i divided by minus 1 minus 2i plus 1 minus 2i. So minus 1 plus 1 get cancels. Here I can take minus 2 as a common term in the numerator. So when you take the minus 2 as common term, you will get 2 plus I. In the denominator it is minus 4i. So minus minus get cancelled. 2 1s are 2 2s are. So f of beta value is 2 plus I divided by 2i. So f of beta value I have obtained. Therefore with respect to beta, what is the value I have? Z minus 3 divided by z minus alpha into z minus beta dz will be 2 pi I into f of beta value is 2 plus I divided by 2i. Here 2i get cancelled. Therefore the solution is pi into 2 plus I. Solution of a given problem is pi into 2 plus I. I am repeating once again. See here, when the curve is given in this form, first you have to find the roots and you have to discuss with reference to both alpha and beta. First I have obtained the value of alpha and beta, whether it is inside the given curve or outside the given curve, by considering the curve and replacing z with the given alpha values. If it is greater than given radius, then it lies outside. If it is less than given radius, then it lies inside. So as I already told you, when it lies outside, we can apply Cauchy's theorem, thereby it goes to 0. When it lies inside, we can apply Cauchy's integral formula, thereby we have to apply the formula. So that is what I have done. See here, I am applying with reference to alpha, so I am considering alpha as it is, but whereas I am considering beta along with the function f of z, where f of z will be I'll write small f only just to avoid confusion. So f of z is z minus 3 by z minus beta. So z minus alpha as it is. Since alpha lies outside the circle, by Cauchy's integral theorem the value goes to 0. Now let me discuss the same function value with reference to beta. Since beta lies inside, therefore what is the theorem says? F of z by z minus a is 2 pi I into f of a. So since I am discussing with respect to beta, so I have written beta as it is. Let me take alpha alpha along with the numerator as f of z. So I have written f of z as z minus 3 by z minus alpha. Now it is of the form standard form. In place of a what I have? Beta. So f of a replaced with beta, I have obtained this. Now what I need is f of beta value. So f of z I have replaced z with beta, and beta and alpha value I have obtained in the previous case, and substitute after simplification you will get f of beta value and replace in the obtained formula. So this is what the solution of a given problem is. Hope so it is clear. So let me solve one more problem. Here is the problem. So we have to evaluate the integral, but in the denominator what we have? Z square plus 4 plus into z square plus 1. So it is very difficult to resolve this kind of problems. It is not more difficult by using partial fraction. Anyhow we can solve it by using the method of ax plus b and cx plus d, right? But while applying the formula of Cauchy's integral theorem and Cauchy's integral formula, the things may take complicate. So instead of that, let me simplify, as I can write z square plus 4 into z square plus 1. I have to factorize this, right? So let me equate it to 0. So if you do that, I can write as z square plus 4 is equal to 0 and z square plus 1 is equal to 0. Thereby z square is equal to minus 4, z square is equal to minus 1. Or else I can write as z is equal to plus or minus 2i, right? Square root of minus 4 I will get. So I can write this as square root of minus 1 is I. Thereby I can write z is equal to plus or minus 2i. Similarly z is equal to plus or minus I. Fine. So I have obtained two values for z. Meaning is that I can write the denominator as, instead of applying ax plus b and bx plus c form, I can write the denominator as I is equal to 3z square plus 4z minus 1 divided by, this can be written in terms of factors. So meaning is that I can write this as z plus 2i into, in another value is z minus 2i. And similarly I can write this as z plus I into z minus I. So if you multiply these two terms, you will get z square plus 4. If you multiply these two terms, you will get z square plus 1. I have factorized this into two terms. So I can write these two terms as product of these four terms. Fine. Z plus 2i into z minus 2i into z plus I into z minus I into dz. So I have written a given problem by using a factors. Fine. Now let me consider a denominator of a fraction. So 1 divided by, consider 1 divided by z plus 2i into z minus 2i into z plus I into z minus I. So one more thing is that whatever the problems I have solved so far, I'll send you notes. But wherever I am telling you that, you just copy the notes from the video only. And moreover, this problem also I will not send you the video notes again. You have to write by watching the video only. Only problems you have to write by watching video. So I am repeating again and again. Solve or write this problem by watching the video. Now how can I write this as a divided by z plus 2i. If you want, I'll send the pic of the same only, or else if you want, you can take the screenshot. So z divided by b divided by z minus 2i plus c divided by z plus I plus d divided by z minus I. By the partial fraction I can write this. Further, 1 is equal to a into z plus 2i goes off. So you will get z minus 2i into z plus I into z minus I. Similarly, plus b into z minus 2i will not be there. So you will get z plus 2i into z plus I into z minus I. Similarly, plus c into z plus I will not be there. Remaining term z plus 2i into z minus 2i into z minus I. Similarly, z minus I will not be there. So d into z plus 2i into z minus 2i into z plus I. Fine. Hope so it is clear. Now instead of giving values for each and every term, that is z values, and finding a b c d values, in this particular problem, what I'm going to do is I'm going to replace directly in a given problem. So see here, what I'm going to do is, given integral is this one. So I have written this as the product of factors. So I can write this integral as, let me take I. So I can write I as I is equal to a into, I'm writing this again, see here, a into this value I can write, right? So a into numerator I'm going to write 3z square plus 4z minus 1 divided by z plus 2i into dz plus b into, I'm just multiplying this step. Why? Because when you are going to substitute all the values, the things get complicated. So I am splitting this term directly here. So b into, I'm going to multiply the numerator, that is 3z square plus 4z minus 1 divided by b divided by z minus 2i into dz plus c into what we have, numerator as it is 3z square plus 4z minus 1, you have to put the closed integral, otherwise it will be different meaning. So z plus I into dz. Next, plus d into integral over closed curve, numerator as it is 3z square plus 4z minus 1 divided by z minus I into dz. What I have done is I have splitted the given term by applying the partial fraction directly. Instead of solving a, b, c, d values in the partial fraction, I am doing it directly. Why? Because we are not intention in finding a, b, c, d value. Instead we are we are intended to find the value of a given integral. Fine. Now let me look at the problem. It is very easy now. See here, compare it with the standard form. No matter whatever may be the value of a here, it is of the form f of z divided by z minus a, right? What is the value I have here? 2i. Clear? Now we have to know whether 2i lies inside the circle or outside the given circle. Now what is the circle equation is given? Mod z is equal to 3. Meaning is circle is somewhere here. So radius from here to here is 3 units. Fine? It is 3 units. Now 2i meaning is, it is of the form x plus iy. Right, so x coefficient is 0, I coefficient is 2. So 0, 2. Clearly 2 will be inside 3. Right, 2 will be inside 3. Here also radius, in the sense here also it is 3 units. So 0, 2 will be somewhere here. It is inside. So 2i lies inside. Again in place of here it is minus 2i, right? So anyhow 2i lies inside. Now coming to, I'll write here only inside. Fine. So minus 2i. Minus 2i in the sense 0, minus 2. Minus 2. So 3, radius 3 in the sense, let me check for minus 3. Oh, I'm sorry, minus 3, it is not the case. It is I, right? So I value, I in the sense, we have to check for minus 2i, right? So minus 2i in the sense, 0, minus 2 will be somewhere here. So here it is quadrant wise, it is minus 3, y value is negative here, y value is positive, here x value is negative. So minus 3 here, minus 3 is somewhere here. So minus 2 will be always inside. So minus 2i is also inside the circle. Fine. Now coming to the I in the sense 0, 1. Obviously it is also inside the circle. Next coming to minus I. Minus I is also of the form 0, minus 1. Now look at 0, minus 1. So 0, minus 1 is also inside the circle. So clearly 2i, minus 2i, I and minus I. All the 4 points are lying inside the given circle or given curve. I am repeating once again as I already explained clearly. So these are for your reference. 2i, minus 2i, I and minus I lies inside the given circle. So I have to apply Cauchy's integral formula. Why? Because it is inside the circle. Therefore by Cauchy's integral formula, let me write the formula. F of z divided by z, you have to write full form. Z minus a into dz is equal to 2 pi I into f of a. Please remember, you have to write full form. Now I can write the integral as I is equal to a into 2 pi I into a value is minus 2i. Compare it with z minus a form. So it is f of minus 2i. Right? Plus b into, it is also the same, 2 pi I into f of, in place of I you have 2i. Similarly plus c into 2 pi I into f of, in place of a I have minus I. Plus d into 2 pi I into f of, in place of I have I. Hope so it is clear. I am applying Cauchy's integral formula by comparing it with the standard form f of z divided by z minus a. Fine. So in all the cases f of z is same, right? So before that, let me simplify this step. What is the common term I have? 2 pi I. So integral I can be written as 2 pi is common. So a into f of minus 2i plus b into f of 2i plus c into f of minus I plus d into f of I. Fine. Now I have to find f of minus 2i, f of 2i, f of minus I, f of I. So let me take this as equation 1 and let me evaluate all the values. F of minus 2i I need. F of minus 2i. So before that, let me write f of z here only. So f of z is compared with the standard form. F of z is 3z square plus 4z minus 1. Now replace z with minus 2i. So you will get 3 into minus 2i square plus 4 into minus 2i minus 1. So you will get 3 into minus square is plus, I square value is minus 1. So 2 square is minus 4 plus 4 into minus 2i minus 1. Again minus 12 minus 8i minus 1. Again what it is? Minus 13 minus 8i. So f of minus 2i value is minus 13 minus 8i. Similarly, find out f of 2i value. Let me continue here. So f of 2i will be replace z with 2i. So 3 into 2i square plus 4 into 2i minus 1. So 2 square is 4, I square is minus 1. Again I will write here one more step. 4 2 is 8i minus 1. So 4 into minus 1 is minus. So minus 12 plus 8i minus 1. So you will get minus 12 minus 1 minus 13 plus 8i. So f of 2i value is minus 13 plus 8i. Clear? Now let me find f of minus I value. So f of minus I will be replace z with minus I. 3 into minus I square plus 4 into minus I minus 1. So minus I square I have. Minus square will be plus. Again I square value is minus 1. So you will get minus 3 minus 4i minus 1. So you will get minus 3 minus 1 is minus 4 minus 4i. So f of minus I value I have obtained. Next what else I need is f of I value. F of I is equal to 3 into, let me replace z with I. You will get I square plus 4 into I minus 1. 3 into I square value is minus 1 plus 4i minus 1. So you will get minus 3 plus 4i minus 1. Minus 3 minus 1 is minus 4 plus 4i. So f of I value also minus 4 plus 4i. So I have obtained all the values. So before substituting, what we need is A, B, C, D values are unknown. Again we need to find A, B, C, D value. The problem is quite lengthy, but go through all the steps. I have explained all the steps in detail, and please copy by seeing this video. This problem I will not send you again. Further, if you have any doubt, you can contact me either by call or through WhatsApp message. Fine. As say equation A. Fine. Now I will use equation A. From equation A, let me put the value of z as I. So remember, when you are going to substitute z is equal to I, the terms containing z minus I will be cancelled. See here, when you substitute z is equal to I minus I will be 0. So A will not be there. Again I minus I is 0, B will not be there, I minus I is 0, C will not be there. So only term is D. So let me substitute. 1 is equal to D into, either you can solve here or else you can solve here only. It's up to you. So z is equal to I am going to substitute. I plus 2i, I minus 2i into I plus I. Clear? So what you are going to get? 3i, I minus 2i is minus I plus I is 2i. So after multiplication, D into, first let me multiply constant, 3 2 is 6. Next I into I is I square. I square value is minus 1. Minus into minus is plus 1. Plus 1 into I. So what is the D value? 1 divided by 6i. Clear? So D value I have obtained. Similarly, let me substitute, put z is equal to 2i. So when you put z is equal to 2i, wherever you have minus 2i, it will be 0. So here 2i minus 2i is 0. Again it will not be 0. Again 2i plus 2i you have. 2i minus 2i is 0. 2i minus 2i is 0. So you will get b value. So let me substitute. 1 is equal to b into 2i plus 2i into 2i plus I, 2i minus I. So simplify, you will get 4i plus into 3i, 2i minus I is I. So 4 into 3 is 12, I into I is I square value is minus 1 into I is minus I. Clear? So you will get B as minus 1 divided by 12i. B is equal to minus 1 divided by 12i. Fine. Now let me substitute, put Z as minus 2i. So when you substitute Z is equal to minus 2i, it is just a partial fraction. Whatever the values you have, you just go on substituting. So you equate Z plus 2i is equal to 0. So you will get Z is equal to minus 2i. So let me substitute minus 2i. Again Z minus 2i is equal to 0. So substitute Z is equal to 2i. You will get B value. Again Z is equal to minus I and Z is equal to plus I. So Z is equal to minus 2i when you are going to substitute, C will not be there because minus 2i plus 2i get cancelled. Again D will not be there because minus 2i plus 2i get cancelled. Again B will not be there, minus 2i plus 2i get cancelled. But when you are going to substitute Z is equal to minus 2i, A will be there. So 1 is equal to A into minus 2i into minus 2i plus I into minus 2i minus I. It is just a simple partial fraction. So 1 is equal to A into minus 2i is minus 4 into I. Minus 2i plus is minus I. Minus 2i minus I is minus 3i. Minus into minus plus, plus into minus minus. 4 3s are 12. Minus 12. I into I is I square. I square value is minus 1. Minus 1 into I is minus I. So minus of minus become plus I. So A value is 1 divided by 12i. So if you are finding it is fast, you just set the speed of a video and you can watch again. Fine. Now let me substitute Z is equal to minus I. I have already taken a plus I, so I am going to substitute minus I. So I have already obtained A, D and B value. Remaining no need to C, so you have to obtain C value. 1 is equal to C into minus I plus 2I minus I minus 2I minus I minus I. Fine. So you'll get 1 is equal to C into minus 1 plus 2i is in plus I. Again minus 3i minus 2i. Fine. 3 2s are 6. So minus into minus plus 6. I into I, let me write 6 here. I into I square. I square value is minus 1. Minus 1 into I is minus I. So C value is minus 1 divided by 6i. Now you can see that I have obtained f of minus 2i, f of 2i, f of minus I, f of I and all a, b, c, d values that we required in equation 1. Now let me substitute all these values in equation 1. So with this equation 1 can be written as integral I is equal to 2 pi I into a value is 1 by 12 into I. F of minus 2i. F of minus 2i is minus 13 minus 8i plus b value is minus 1 by 12i. So let me make it minus 1 by 12i. B value is minus, that is why. So f of 2i. F of 2i is minus 13 plus 8i. Minus 13 plus 8i. Again C is minus 1 by 6i into f of minus I value. F of minus I value is minus 4 minus 4i. So I am going to substitute here minus 4 minus 4i plus d value is 1 by 6i into f of I. F of I value is minus 4 plus 4i. So I have substituted. Now we need to simplify this. So you have to practice more, then only you will get clarity. Fine. Now what I am going to do is, see here in the denominator you can take 2i as a common, right? See here 2 6 again 2 3 so let me take 2i common so that this 2i cancel with the common term. So I'll get pi here. Since I have taken 2i common, I am writing directly in order to avoid the steps. You will get more steps here. I have taken 2i common, so I have cancelled 2i with a common factor. Since I have taken 2i, right? So I have to write this as 6i, right? Hope so. It is I will be common, right? So it is cancelled. 1 by 6 you will get here. 1 by 6 into minus 13 minus 8i. Again minus 1 by 6 you will get. Why? Because 2i it is common you have taken. So minus 13 plus 8i. Now 2i you have taken. So you will get minus 1 by 3 minus 4 minus 4i. Again 2i you have taken. So you will get plus 1 by 3 into minus 4 plus 4i. Now you have to simplify all these terms. Fine. Now what I am going to do is, I will just group the terms which are similar so as to take LCM easily. Fine. So let me continue here. What you're going to get is pi into, just I'm going to multiply, minus 13 by 6 minus 8i by 6, minus of minus is plus 13 by 6 minus 8i by 6. You have to take care of signs. So minus into minus plus 4 by 3, minus into minus plus 4i by 3, again minus 4 by 3 plus 4i by 3. So minus 13 by 6 plus 13 by 6 goes off. Again plus 4 by 3 minus 4 by 3 will not be there. Again what you left with, let me write here, pi into minus 8i by 6 minus 8i by 6. Again plus 4i by 3 plus 4i by 3. Right? Now let me simplify this. Let me take LCM. So you will get minus 8i plus 3 LCM. So you will get 4i plus 4i. Clear? So minus 8i is minus 16i divided by 6. So 2 3s are 2 8s are plus 4i is 8i by 3. So you will get I value as pi into minus 8i by 3 plus 8i by 3. Clear? So again minus 8i plus 8i cancel. So nothing will be there. So the integral value is 0. So all this lengthy evaluation gives us simple value, it is 0. Please go through all the steps. So all the steps are clearly explained here. If you have any doubts further, you can contact me. I have already told you. So all the steps are clearly mentioned. See here, first page. I have evaluated the problem and I have solved each and every values needed in detail, and after simplification you have obtained I value is 0. So hope it is clear. So similar problems will be continued in next session. So practice the problems well. Thank you. See you in the next session.